Assalamu alaikum, welcome back to my channel. This is the third video related to substation. So what I am teaching here very basic things. So this is not advanced things. So consider as a basic thing. So today I am going to teach you how to select cable, also the basic things. In the advanced thing you will know by your experience. This is only for the learning purpose only, strictly for learning purpose only. Okay. So you can design, you can check, mostly you can check the design which is done by designing engineer. So it's okay or not for that kind of a thing. This knowledge will be helpful. Also, if you are going to design, it will be helpful for the base concept. Okay, if you want advanced designs, this is you see this is villa. So if it is going to the factory, it's a different thing. Okay, and there's too many things in advance. So understanding the concept, this video will be very helpful. So in there is some advanced thing. I want to I will give you the basic concept of this. So there's a panel called MCC panel. So this is more, yeah, MCC panel. So let me make a big, okay, let's go MCC panel. So this panel is motor controls center. So if you go to the Google, if you check MCC panel, full form. So motor control center. So MCC panel look like this. If you see this one, also same like switch gear, but little different. So this MCC panel mostly used for the form. You can understand by the form motor control center. Like you can connect ACs and some which is related to motors. Okay, and there is another panel. So this panels are basic panel DB, SMDB. This is DB, SMDB, MDB. This is the main panel, but base panel. This is some additional panel come. This is one of panel called MCC panel. There's the call another This MCC panel contains something VFD drive. So this VFD drive is VFD. This called variable frequency drive. Let's match this one. So you should know these things. So if you go to Google VFD drive, you can type VFD drive. Okay, we can go VFD panel. So it's a small panel, so we call VFD drive. If you go VFD drive, variable frequency drive. It's a panel, so sometime it will come inside. I believe I have did some drawing, but okay, let's go with the panel. So no need to confuse. Maybe that one I did special design. So we will go with the VFD drive panel. So what it will do, it will reduce the frequency or increase the frequency to make speed the motor. If you go to the Google, you will see Google Master telling the VFD panel, variable friction, also known as the VFD control panel, designed to control the speed of the electric motor feed pumps. They are widely used in drilling, pumping, and other large. So it will control the speed, like RPM, rotate per minute, rotation per minute, RPM. Okay, something like that. And there is some panel called ATS panel. This ATS panel widely used in many area where they are using. Let's make this ATS panel very widely used. Uh, so widely used wherever come emergency and normal power. So it will switch In case of emergency, it will switch the connection. So if you go to the Google Master, let's type ATS panel, like we call auto transfer switch. Auto transfer switch panel or ATS panel. Transfer panel used with the diesel generator to automatically switch between the main and generator in the event of power failure. So I hope you understand. It will switch from the emergency. Emergency means it's coming from the generator. So something like this, there is a more kind of panels. So let's go to our design. So in my villa design, so here, this is a normal apartment. I have used some sockets and ACs, everything. So if you go to the like office, big office or a school or something, some warehouse, something like that, you will see this panel there. So MCC panel, they will use for the AHU, air handling unit, FCU, fan coil unit. These are the AC panels. You can check in the Google. So they will use this MCC panel to control that things. So if this build warehouse have generator, so they will use this ATS panel. You will see there. You will not see these panels on regular flat or regular villa areas. So these are in the mostly uh, offices, meaning big offices, building in buildings or not buildings. Normally offices, big offices, warehouse, something like that. You will see this panel. So this is the advanced things. So I want to explain you regarding this one. So this is generator, this generator. So this is a normal power. So you see mechanical interlock. This mechanical interlock, this one is same play this character. ATS panel and mechanical interlock. Switch the normal power to emergency power. So there will be a design which one should be run. So you see here DB. So I will type again. There will be DB. This is normal. Let's copy this one. Okay. So I don't have to. Let's go to this next one also. Okay. So there is a DB. This is normal DB. And there will be EDB, emergency DB. There is SMDB, submain distribution board. There will ESMDB. Okay. And MDB, main distribution board, EMDB. So these are separately come from the generator. So if you are feeding total to this generator, total feeding MDB, this MDB, so one ATS panel is enough. So because this will feed full MDB, this MDB main distribution board, it will works as MDB slash ESMDB, EMDB also. Meaning this one will work. Actually, we don't call like that, but we call MDB. But it will work emergency time also, normal time also. We don't call EMDB if it is not separate. So this is MDB. But here we have generator feed. But some place, if you go to the AutoCAD, so there will be a panel here. So this one called SMDB. Okay. And there will be SMDB. Okay. So look at it carefully. And we will come another one. Okay. So this SMDB, ESMDB with feed from ATS. Say it is fine. Okay. So there will be MDB here. Okay. MDB. And there will be another panel. This is some case, okay, not it's as per the designer. There will be another EMDB. Okay. So this one feed power here, and the same time feed power from here and also here. Then from here to here. Okay. Let's make it like this. Okay. Again, this two, this one from the government supply, like LB panel. Okay. So we can call MDB or MB panel. Okay. This some area they put MDB, some area they put MB panel. Okay. So this is from the LB, and this one from the government power supply. Outside from transformer, this TX. Okay, let's do it again. Now TX will become above here. Okay, this is a TX. This is LV. Okay. And this one from government supply. So I will put GV, GVS, government, GS. Let's put GS. Government supply. This one for understanding purpose. Okay. But here, directly, you will have generator. Gen. Okay. There will be ACB between this one. For the breaker. So this is ACB. Okay. So there will be diesel tank, everything, whatever will come, which is related with it. So this one normal time, this one will go from government supply through ATS, ESNDB will be fed. But in the emergency time, so what will happen? This automatic transfer switch will switch the panel to feed from EMDB, generator will start, then this will go like this and supply the power. So whatever connected to the SMDB will not work anymore. Okay, in the emergency time, whatever connected to the ESMDB will work. So maybe this one normally ESMDB, they will connect which are the equipment needed without shutdown, and maybe it should be work in every time. Will be connected to this ESMDB. Not directly ESMDB, this one will go to EDB. Let's put inside. Then from the EDB, it will go to the whatever equipment or whatever device we needed. So something like that CCTV room. This one in normal time also the emergency time it should work. If should work, it will be connected to the EDB. CCTV like access control systems. Whatever very important system will be connected to EDB. So SNDB is normal. Okay. Let's say we have one building and corridor. In case of power off, emergency light should be work. So emergency light we have two types. One type is battery backup. One type it is from the central battery system. So this central battery system always charge from the emergency DB. So it's already normally it will charge from the normal time. The emergency time, this will be charged from EDB to the emergency battery system. So in that time, what will happen when the power off, the generator will work, it will feed. So this ATS panel work like this. This is what I am trying to explain you here. Okay. So some design, like let's say laboratory or security center, everything, they will not have like this. Okay. They will always have like this. It will connect here, and from here direct to, even you will not see your ESMDB something like that. SMDB directly, but normal time, emergency time. So this one no more EMDB. Yeah, there will be, no, this one also not available. Actually, this one also no. This one can be done like that also, but normally this ATS panel will be here, because this entire building work in normal time also, emergency time also. This one will go to directly here, and from here it will go here. Okay, this is one kind of design. So generator to ATS, not directly ATS, there will be another panel, actually a synchronizing panel. Let me delete this one so I will be clear for you. So this is the MDB. Okay, this is ATS. ATS, but same time it will like synchronizing panel also. In my previous drawing, I have explained you. So from here, synchronizing panel we need if we have multiple generator. Okay. So from here to here directly. Okay. So the mechanical interlock, I explained you mechanical interlock, something like this. But this one actually, this one also here. Actually, this one not here. This one connected to here, because that one will be inside this panel. Inside this panel. That's the correct design. What I ever draw, that one also correct, but that one need a special equipment, everything. But when they are ordering time, they will make this MDB panel. Then switch gear. They will ask in emergency time also should work. I have on, let's say, SLB, single line diagram with mechanical interlock. Okay. Let's go here. And I need to, I want to, yes. See this one? Yes. No, it's a better explanation. I need some better explanation. Okay, let's say single line diagram, electrical, single line diagram. Okay, yeah, this one. Okay, so this is the full sheet. Let's go with this. See this panel. This one also we have two panel. There is a single panel which come together. Something like this. See, this is connected to, but they have one panel. This is one panel, but she connected to transformer. Okay, but in this one case, in case in here, instead of this, there will be generator, and there's the one panel will come between. So generator will not directly come. Will be there will be a breaker and some panel. It's designed like synchronizing panel or something like that. Then it will connect to here. I was having one single line diagram related to that, but for now I don't have. So this is the interlock. This is also transformer. Uh, yeah, something like this. So this is a mechanical interlock. This is full panel. Okay, and this is the breaker. Something like this, it will come. So you can search in the internet. I couldn't give you the full idea, but this is the concept. So I hope you understand very well these things. So now we will go back to this is just an advanced explanation only. Only the concept I won't explain you. So you search yourself also more. Okay, now we will go to the cable selection. So if you go to the Kahama regulation, if you are in your country, check your regulation, but it is for the Qatar only. So if you go below, so for the cable selection, okay. So here we have two core and insulated steel wire armor. So type of cable you have to know first which type of cable you are going to use. So here we are mostly using the 4 core cable, 3 and 4 core cables. Okay. So you will see this is cable sizes here, and this is you see where it is run. So not this one, this one. Current rating for cable laid directly in the ground ampere. So if you have, you know the ampere, how to take the ampere, okay? So if you go to your table, so here you see amperage is 40.61. So we will not go to the actual ampere. I am checking this one, okay, for the dB, okay? I hope you remember I am making for the dB actual amp for the XM dB from the demand load. dB from the actual load, SMDB from the demand load. Okay. Sometime I missed the continuity because of some interruption. But try to understand. If you not understand, go from the beginning again. You can comment. If I can possible, I will reply for your doubts. Okay. So here you see where it is running. So we know how to take the amperage. So this is the actual load. So we calculate from 1.55. You check what is 1.55 from my previous video. Okay. How we take this 1.55 load. Sorry, formula. So this is load. I multiple by 1.55. So I am having this ampere. Okay. And if you go here, cable selection, and this 1.55 can be changed as per the power factor also. If you are using 0.8 power factor, it will become 1.7 something. Okay. So I am not using 0.7, 0.8 power factor. I am using 0.9 power factor. Okay. So if you go to the Karama cable, I have 40 ampere here, but I will not use 40. I will go for the 60. but the actual I need 40. Okay. So if you go here, see this one 33 and 50 between. So 40 is 33, 50 between. Okay. So I want to use 60 ampere MCCB, so I can go for the 4 core 16. Wire. 4 core 10 is enough, but still I will go with the 4 core 16 with two reasons. The one reason, because I am going to use the MCCB bigger one, 60 ampere. So if you go to the Google, uh, there's the one concept, uh, but I want to tell you that concept also. 60 ampere, 60 amps, sorry, amps, 60 amp wire size. Let's check wire size. No, 60 amp MCCB, MCCB meaning molded cut circuit breaker. Okay, required wire size, actually cable size, cable size. It's showing AWG, meaning this is the American standard. Let's see cable chart. Mm, okay, it is going to something else. Okay, cross-sectional area from typically current rated recommended circuit breaker amps. Now this one. So if you see 16, uh, typically current rating. Sorry, not 60. We are going to the 14. Okay. So you see 10. They are putting 10. But I am going for the 60. So they need 16 ampere cable we need. Okay. So something like this. You will see here. Then I'm going for the 60 ampere more, circuit breaker. So the possible current is the wire is 16. Okay. You can check this one. This is the one of type we are selecting the cable. At the same time, we have to go to check this one also. Okay. So I have for 640 ampere. So still I can go with the 50. But I am putting 60 ampere MCCB because I select 60 ampere because I don't want to go the actual. I want to go little in more. So I will go with the 60 ampere MCCB. So I will choose here cable for core 60 for the DB. So let's go to the SMDB. So I have 191.58, right? Around 200 ampere. So let's go to the Karama. Then I will go this one, 215. Oh, I will go for the 250. So I am better use go for the 240 cable. Okay. 4 core 240. This is how we select the cable. So there's another problem. If we have more distance, so we have to check the voltage drain. So you see this voltage drop per ampere per meter. This is what. So each meter there's a certain amount of voltage drop they have calculated here. This one you can see any catalog. Even if you are in Sri Lanka or Bangladesh or Pakistan, they have their own cable manufacturer, or maybe they are importing from their company. They have already mentioned this voltage drop per meter, uh, per amperage per meter. This is called MP. So if you go in the Kahrama table in the Qatar, let's go for that table. Yeah, here it is. This voltage drop. The last one is 4%. So starting from here, okay, this is MDB, this is transformer, MDB, SMDB, NDB, and wiring device. Okay, you can see this one will stay 2.5% of supply. So transformer 10%. So this is the maximum we can go with the 2.5. The final is 4. So this one also we can go for the 2.5. Okay. So how we will calculate? calculate from here, this one. So tabulated voltage drop, meaning this MV. I don't want to go here because this is easier for me. If you want, if you can use this one, you can use this one. Okay, now I will go this one, tabulated can MV. Design current, meaning what the ampere you have, the length. And you have to divide by 1000 and convert it into the percentage. Then you, if it is increased more than 2.5, then you have to go, you have to change cable size to the next one. If 240 have, let's say I choose 240 and I calculate the length, it's increasing percentage from 2.5. Let's say I go 3% and then I have to go to the other size like 4 core 300. Okay, so now let's check how we will, 1 minute. Okay, again voltage drop. Okay, so tabulated voltage drop. Let's go for the Excel. So I saw 240 is 0.2. Okay, 0.2. Okay, here let's make big size. Okay, okay. Then the ampere I have 191, I think. Yes, 191.58. So let's put 200. This is amperage. Okay, go to the tabulated length. Let's say 100 meter. Okay, so this is the formula equal. Let's match this up now. Okay, equal, open bracket. This one multiple by this, close bracket, divided by 1000. So I have 4. Okay, so 4 meaning not 4 percentage. Okay, this 4 should be converted to percentage. That meaning 0 point, how much? 0 point. So it will be 0 point something. Let's calculate. So equal this 4 divided by, because our contra voltage we have to go with the 415. So let's put 415 and multiple by 100. So it's coming almost 0.96 percentage. Okay, I hope you understand this one. So let's put it, this is 415. 100 percentage. So we don't have 415 voltage drop. We have only 4 volt, 4 voltage. That meaning 0 point. This is 4 volt drop. That meaning it's percent by percentage 0.96. So if you come here, we have 2.5 percentage. So this cable is okay. But let's check. I have 500 meter. Okay. So this one. So I should not type 4 here. Instead of that one, I'm going to click this one. Enter. So here I have 4.82. Let's go 200 meter. 1.3. Let's go 300. No. 250. Okay. So in this cable, I can maximum go 250 meter. If I have 300 meter, let's say 300 meters, so it's increasing. So I have to go to the next length, next cable. So we'll go to the next cable. Okay, it was 3 and 4 core. So next cable is 0.18. So this one 300 0.18. So still I cannot. So then we have to go to the another one. So we cannot go another one because maybe not available. So what we will do? So we can go with two cables, meaning maybe we can go with two runs. Okay, like let's say this 240, we can make two cables. Not 240, we can go with 300, right? So we can go with another size. So maybe we can go with 185 by 2 run, 0.24 by 2 run. Okay. So in that case, we have to go for the two cable run because we don't have here. Maybe we can go with because this is next size. Let's say we have 400, so we can go with 185 by 2. So it can be fixed. So I don't want to go more details. So I hope this is enough. So you can learn by some. Don't depend on me and only me because of this is not enough for you. But this is the base concept. So you have to search also by yourself. Okay. To have a good knowledge. So this is the base concept how to select cables. Okay. So the cable selections also differ. So this is what you want to see also. How you run cables also will be depend. Okay. So there's some cable, bigger size. You have to check that the cable. Okay. Yes, you have 400 is 0.17, but 3 and 4 core insulated steel wire armor. That one XLP is still, let's use 0.17, 0.17. So it is coming. It's okay now, 2.5, but still, if you don't ever, if you are available, if you are using this cable, you can go with the 400. If you don't have available, you can go with the 185 by 2 run. Also can be fix your problem because if you are using 3 and 4 for XLPV, you can go with the 400 cable if you are available. Otherwise, 185 by 2 also can be fixed. Otherwise, you have to go 240 by 2. It's depend on the distance, how much you have. Okay. I hope you understand very well. So the next thing, inside the substation, this is feeding the power out to the building, will everything. But inside the substation itself, we need some lights, we need some sockets, we need some emergency things because in case of something happen here, we need emergency thing also. So the same concept, there will be a DB here, like there will be a DB here called DB TX, and there will be a DB here. Let's type DB TX, and there will be a DB called DBMB, DBLB, something like that. Okay, DBMB, DBMB, DBMB this one, medium voltage. Okay, this is medium voltage MBB. Uh, okay, this name always confusing. This is MB, this is LB. Okay, let's go to the Google. LV panel, LV Qatar. Let's go for the LV Qatar. LV panel meaning. The low voltage panel employed to distribute a regulated electric power. So let's go with this one. This name little confusing because LV diagram. Okay, LV panel diagram. So this is LV panel. Okay, this is LV panel. Okay. 100 kVA. This is transformer. 1 minute. Sometimes I confuse myself. Okay, MV is here. Okay, this is MV, this is LV. So before transformer is MV. This is MV. So I'm wrong from the beginning. So the people who watched the previous video, I was confused with the name. So this is MV, this is LV. I am sorry because I confuse also because we are used to work one substation into 2 year, 3 year, maybe one substation we work because the project will goes about 2, 3 years. If we are in, I am in the contracting field. So this consultant field, every month you will face one substation. That's why I am confused here. So if you are watching in sequence, you will be not misguided. And I have to correct in my previous two video because I put it as LV is MV. So the people, I already uploaded that one, the small mistake by name. So that's why I'm trying to say every time, don't depend on me 100%. You have to check little also. If any mistake I made by name, because I'm also normal human, if any mistake, just comment it. So by replying by comment, I will fix these things. Okay. And and also, so I hope you understand. So there's a small mistake by myself. This one MV, this is MV, this is LV. Please watch my old video. So in case of this small mistake, I will be fixing the other video. So I cannot modify the previous video. It's already uploaded. But anyhow, uh, you have to cross check everything, whatever I said, not blindly follow me. And I hope you understand very well. So I explained already cable selection, how it will work, everything. So by name, I have made one mistake. So inshallah, in next video, I will try to cross check again and again before I am making the video. This is a good example for me. I should check the naming. I already confused the name, so next video I will take care on this one. So until we meet next video, take care. Assalamu alaikum. We will meet in next video. So don't forget to comments if you found any mistake by name or anything because I also used to do mistake. Please comment So the people who watching the video, they will read the comment, they will understand also. At the same time, it will be helpful for me. Take care. Bye. Assalamu alaikum.